Here we have an example of checking a set of polynomial is a spanning set of the vector space P3, the space of all polynomial of in X of degree less than 3, right? So this space P3 is the space of polynomial a0 plus a1x plus a2x squared for all the coefficients as real number. And we need to check whether three vectors or three polynomials 1 minus x squared, x plus 2 and x squared span P3. And we know P3 is given with two operations, addition and scalar multiplication. Okay, we need to check if Z3 span P3, meaning that any polynomial in P3 can be written as a linear combination of the three vectors, right? So now pick any polynomial Px in P3. We check whether this Px can be written as a linear combination of the three polynomials given here. This means that we need to check whether there exists scalar alpha 1, alpha 2, alpha 3 in R such that Px is alpha 1 times the first polynomial plus alpha 2 times the second one plus alpha 3 times the last polynomial. So now on the left hand side we have Px a0 plus a1x plus a2x squared. On the right hand side we have this one, alpha 1 times the first polynomial, alpha 2 times the second one, alpha 3 times the last one. This one we can transform it to this form that's a scalar plus another scalar times x plus another scalar times x squared, right? These two polynomials are equal if and only if the coefficient are the same, right? So a0 here corresponds to alpha 1 plus 2 times alpha 2. a1x corresponds to alpha 2x, so a1 is equal to alpha 2. a2x squared is correspond to minus alpha 1 plus alpha 3x squared. So these two coefficients are equal. At the end we have this system equation, and this system equation with variables alpha 1, alpha 2, alpha 3, right? So alpha 1 is a0 minus 2 times alpha 2, right? Alpha 2 is a1, so alpha 1 is a0 minus 2 times a1. Alpha 2 is a1 and alpha 3 is a2 plus alpha 1, a2 plus alpha 1, so a2 plus, so we have any polynomial Px can be written Px in P3 a linear combination of the three given polynomial, right? Three polynomial. Therefore, this polynomial span P3.